Hi, welcome to the Olympiad geometry. In last 2 weeks, I was working on moving to a new place, so I couldn't continue making videos for the audience. And now let's continue. Before we start, if you think this video is helpful, please click the like button, comment, share, and subscribe the channel. Today we're going to continue our study on the correlation of centers. Here is a problem. In triangle ABC, AB equals to AC. So let's draw the figure first. For this problem, I want to introduce you a way of thinking the geometry. Is that when we read one problem set, we try to find everything we can, and then we read the next problem set. So here we have the triangle ABC. And we know that O is the circumcenter of triangle ABC. So because AB equals to AC and O is the circumcenter, that means O is on the median. On the median line of the triangle ABC, right? So let's put O here. D is the midpoint of AB. D is the midpoint of AD. Now let's just think about what we can get from the problem set we read so far. O is a circumcenter. D is a midpoint of AB. That means OD is perpendicular to AB. Which also means ODBM are cyclic, right? We don't know whether it's useful or not, but it's just to help us to have more problem set, right? OD is perpendicular to AB, and OM is perpendicular to BC, so ODBM are cyclic. E is a centroid of triangle ACD, means we need to connect CD. Right, when we connect CD, remember that M is a midpoint of BC, D is a midpoint of AB, which means this point, let's call it P. P is a centroid of triangle ABC, right? So we got P is centroid of triangle ABC. And we want to see that E is a centroid of triangle ACD, which means we want to find the midpoint of CD here, and we connect it. We find the midpoint of AC here, let's call it F. We connect it. So this point is E, right? Now, just stop here. Because this is a midpoint, let's call it N. N is a midpoint of CD. F is a midpoint of AC. AB equals to AC. So DF is in parallel with BC, right? And OF is perpendicular to AC. And N is a midpoint of CD. That make FN in parallel with AD. And we know M is a midpoint of BC, means that FM is in parallel with AB, which means MNF are collinear. Okay, now let's see. We want to prove that OE is perpendicular to CD. OE is perpendicular to CD. Now let's think. We have OD because OD is perpendicular to AB, right? And OF is perpendicular to AC, which means ADOF are cyclic, right? And also we know AB equals to AC. It tells us that triangle ADO is congruent to triangle AFO. Also, AO is perpendicular to df, right? Because A is a midpoint of arc df. So AO is perpendicular to df. Now, if OE is perpendicular to CD, that means OE is perpendicular to DN, right? Or OE is perpendicular to DP. So OE is perpendicular to DP, and P to this point, let's call it K. PK is perpendicular to DE. So if this one is valid, that means O is orthocenter of triangle DPE. So let's just connect PE here, which means if we can prove that O is orthocenter of triangle DPE, we automatically get this conclusion that OE is perpendicular to CD, right? And for this point, we already know that PK is perpendicular to DF. We just need to prove that DO is perpendicular to PE, right? So OE perpendicular to CD is equivalent to prove that DO is perpendicular to PE. And we know that DO is perpendicular to AB, which means DO is equivalent to prove that PE is in parallel with AB, right? And we know that AB is in parallel with MNF. Which means we just need to prove that PE is in parallel with MNF, right? And think about what we have here. P is the centroid of triangle ABC. E is the centroid of triangle ACD. So we know that AE to AN equals 2 to 3, right? Because E is the centroid of triangle ACD. So AE to AN, that's 2 to 3. And because P is the centroid of triangle ABC, so AP to AM equals 2 to 3. Which means AE to AN equals 2, AP to AM, right? AE to AN equals 2, AP to AM. So that means PE is in parallel with MN. Right, so because PE is in parallel with MN, PE is in parallel with AB. That means PE is perpendicular to OD, right? PE is perpendicular to OD. And we already know that PK is perpendicular to DF. That makes O to be the orthocenter of triangle DEP, right? Which means OE is perpendicular to CD. Okay, so for this kind of problem, it shows the way I generally solving the geometry problem. So I don't read all the problem set. I normally just read a piece of problem set and then think about what I can get from the known information and use the conclusion I get as a problem set, as a part of the problem set, and then keep going, right? So in that way, it's easier because you are not overwhelmed by the too much information. So I hope you enjoy this video. See you in next one. Thank you.